This is section 2.4, limits and continuity. In this video, we're going to go through an example problem of when they give us a set of equations and ask us to find the value of a variable to make all those equations continuous. This is number 59 in your book, gives us this set of equations, and we're going to go through this step-by-step guide of how to solve these types of problems as we go through this video. Okay, so first thing we want to think of is just a really basic idea of what continuity is. If I have a graph and if it's continuous, then I should be able to follow my finger along the graph and I should never have to pick it up to move from one point to the other. In other words, wherever one part ends, it flows directly into the next part, right? So when we have a system of equations like this, wherever this top part ends, it should end exactly where this second part picks up. And likewise, where this second part ends, it should end exactly where this third part picks up. And that's what we're going to do. We're going to set our first two equations equal to each other at the x value where they switch. And we're going to do the same with our second two equations. All right, so sounds pretty easy. Let's go through step one. So step one is set equation 1 and equation 2, these two, equal to each other at the x value where they switch, which in this case is x equals -1. So we have x to the -1 is equal to ax plus b, and we're going to plug in our x value, which is -1. So on this side, I get -1 to the negative first power. That just becomes -1 is equal to a times -1 gives me -a plus b. All right, set them equal to each other, but I still have two variables in here, so I'm not sure what to do next. So what I'm going to do here is I'm just going to solve for one of these variables. Doesn't matter which one, pick your favorite. So next part, solve for either a or b. All right, going back over here, it looks a little bit easier to solve for b, so I'm going to add a over to the other side, and that gives me -1 plus a is equal to b. All right, we have this equation. Let's box it off, set it aside for now. This was step one, set these two equations equal to each other at the x value where they switch. All right, let's go on to step two. Step two, we're going to do the same thing with the next set of equations. So in step two, we're going to set equation 2 and equation 3, these two, equal to each other at the x value where they switch off, which is at x equals 1/2. All right, so step 2, I have ax plus b is equal to x to the -1. I plug in my x equals 1/2 into both parts. On the left, I get 1/2 a plus b is equal to 1/2 to the negative first power, just gives me 2. And what I'm going to do from here is whatever variable I solved for in this first step, I'm going to solve for the same variable here. So since I solved for b over here, I'm going to solve for b again in this part. To solve for b, I just subtract 1/2 a over, and I get b is equal to 2 minus 1/2 a. I have this equation. All right, you might see where this is going now. For step 3, we're going to set these two equations equal to each other so that now I only have one variable in my equation and I can solve for it pretty easily. So step 3, set two equations for b equal to each other. And when we do that, we're able to solve for both a, plug it back in, and plug for b and solve for b as well. All right, so let's set these two equal to each other. I have b equals -1 plus a is equal to 2 minus 1/2 a. I add my a over. I have 3 over 2a is equal to 3. Solving for a, it's multiplied by 2 over 3, and I get a is equal to 2. All right, have my value for a. Now I can take this value, plug it into either of my b equals equations, and solve for b. This one looks a little easier, so I'm going to plug it into that one. All right, when I plug in a equals 2, I have -1 plus 2 is equal to b. B is just equal to 1. And that's it. My answer for this question is a equals 2 and b equals 1. If you wanted to check your work, you could plug in your a and b values into your second equation. And from there, plug in -1 for your second equation here, and plug in -1 for your first equation here. Make sure that those two values are equivalent. Then do the same for the last equation. Plug in 1/2 for your third equation, plug in 1/2 for your second equation, and those two values should be equal as well. All right, hope this step-by-step guide for solving these types of problems was helpful. You just set the first two equations equal to each other where the x value flips, and set the next two equations equal to each other where the x value switches, and solve for your variables that way. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in. But all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.